Okay, this is Aaron Murakami, and it's May 2nd, 2015, and we're about 68 or so days until the 2015 Energy Science and Technology Conference, which you can find more details at energyscienceconference.com. And we're here today with Paul Babcock at his one of his workshops here, where he does a lot of experimental research in magnetics. And sitting behind, right next to him, you can see the AR logo, the Advanced Inductive Research and Development Corporation. And Paul's upcoming talk is going to be Magnetic Energy Secrets Part 3, which Part 1 and 2 are at magneticenergysecrets.com. And in the third presentation he'll give on the topic, and by the way, Jim Murray will be giving basically an extension to that part, or we can might as well consider it maybe like a Part 4, where he'll go into some other stuff on the same topic. But Paul's topic will focus sharply on basically avoiding Lenzs Law, and how it doesn't even have to come into play if magnetic motors and generators and stuff are designed in a right way, where you don't get the magnetic clashing. Exactly. And related to a lot of losses that you can't really recover. And do you want to explain a little bit about this motor, which is your patent is based on? And
yeah, this motor we built. We spent years developing our theories. We knew we could recover flyback energy. We had all these positive electrical effects from the switching technology we developed when we were driving inductors. And we had also knew that we could magnetically couple fields without inducing Lentz effects. And virtually every inventor out there that's ever done anything that you could call over unity is really different magnetic configurations that don't invoke Lentz effects. And there's dozens of them out there. It's been done forever and ever. And really the point of the lecture I'm going to give is that we don't really need to worry about zero-point energy and cold fusion and all these esoteric things that have great promise and potential. But right now, today, we have everything we need in our hands to totally revolutionize energy and electricity. We have the switching technology, we have the theory, we know about magnetics, and it's all about media, whether it's John Bettini or Jim Murray, Joseph Newman, all of them. It's about different interactions of magnetic field that avoids Lentz effects. And so back in the day, when they were studying motors and generators, and they came to the conclusion that motors were generators and generators were motors, that it was just an expression of Newton's third law and conservation of energy. And then Maxwellian equations came along and took it to the next step and defined the mathematical numbers. 746 watts of converted electricity is equal to 1 mechanical horsepower, and all that. And all that stuff's great, and it's all exactly true. But the difference is we don't have to do it Mother Nature's way, and we don't have to do it the way motors and generators have been designed since the beginning. Different configurations can negate the drag forces. And Lenz's law is not really a law. It only applies to those configurations of magnetics where you're clashing magnetic bodies together, and one is inducing electricity or inducing magnetic currents into the other body, and vice versa. Well, yeah, that's classic Lentz, and it is what it is. Wouldn't argue with those formulations and that configurations for nothing, because they're true and correct. But that doesn't mean we have to do it that way. And that's what this whole motor was about, was to show that we could couple magnetic bodies in a way that didn't produce induction effects, and that we could create controllable electromagnetic bodies to where we could completely recover the energy we took to make the magnetic body magnetic in the first place, that created the force on the other body, and reuse that energy. And this machine incorporates all those principles. And it's actually fairly complex electrically, and it's a toroid based system But all the magnetic coupling is in space around the magnetic bodies, not through and into the magnetic bodies. And so what that means is we can make force without counter drag force. So when the armature is moving and being pushed, it's a one-way street. The armature can make, or the rotor can make the armature turn, but the armature can't induce any force or electrical flow back into the stator. And we proved that we can create plenty of force and plenty of torque and horsepower using this process. And this motor, it's a pretty crude prototype. When we built this in 2001, we had a lot bigger budget till the planes hit the building, and that killed a lot of our financing we had just because of the mayhem. And so instead of having a $200,000 budget, we had a $20,000 budget, and we went to bubble gum and tape, and we hand built the boards and hand constructed everything. Shotgun pellets, masking tape, plywood, whatever it took, but we got it built. And it conclusively proved the principles, and we got the data off it that proves that we can go way beyond 746 watts per horsepower. You know, that we can generate horsepower at much smaller amounts of energy input, just because Lenz's law is not invoked. Lenz's reactions are not invoked in this concept. Plus, we're also reusing the electricity multiple times with the flyback capture circuits we built that drive the magnetic elements in the motor. We got a lot of data off this thing. We actually haven't spun it up in quite a while. It's been, I don't know, 4 or 5 years since we've been spun this thing because we've been off on other things. And it's a fairly complex machine. And we built it all with old 70s TTL type stuff, but it did, beyond our wildest expectations, prove the principles. And so, you know, that's what it's about.
Now, with your patents, there's like multiple patents that your technology is based on. Whether there's multiple patents for your technology, and the motor and the geometry, I guess you could see on how it's put together, is kind of the motor patent. But then there's also the switching patent that lets you recover.
Yeah, the switching technology is required to drive the inductors, and so we have some pretty heavy duty inductors in here. They're, you know, magnetic elements that create the fields that drive the armature. You know, the things that really made this possible. There's two things that have come along in technology that has really broke this all loose. One of them is neodymium magnets, and the others is the great transistors we have today to work with for switching electricity. Up until the mid-90s, you know, we had this principle. We had a lot of these principles designed, and we had proven that it was possible, but we just didn't have the electronic technology and whatnot to make it economically practical, or, you know, to size it up to any practical size. Well, mid-90s to, you know, early 2000s, you know, transistor technology exploded. IGBTs, you know, field effect transistors got so good and so cheap that and the neodymium magnets became available in mass quantity and low cost. It just opened up the world, you know. It just opened up everything to a new level of technology, and made all these principles possible in a practical sense to create devices. And so that's what we did. We incorporated all those technologies together, built them to our theories. We spent several years in this garage building this thing, and building it was one thing, getting it to work was another. You know, that was harder than building it. But once we got it going, we refined it down to the best level we could, proved everything, got the data, and so, okay, world, we're ready to go out and prove, you know. And being, you know, young, naive inventors, you think the world's going to greet you with open arms because you did this great thing, and, you know, that was wrong. You know, basically we got, I mean, I've seen physicists run out of this building like we'd shot them in the ass with buckshot. I mean, they absolutely did not want to know what we were doing, and when we said that we were mitigating Lentz effects, you know, scream impossible. You guys are crazy hippies. We're out of here. Raising funding was even worse. So, you know, the world just didn't want to see it, and we were starving. So we rethought things and took our switching technology and applied it to motors and other applications, and then we built a company based on that. One of my great dreams is to get back to this and perfect this principle. You know, this prototype, it's pretty crude and rough, but we got enough data on it to prove that we could probably make horsepower for something like 150 to 200 watts of energy to create a horsepower mechanical.
Now, at last year's conference, as part of your presentation and your PowerPoint, you showed a video of this exact machine running. Obviously, this machine is pretty big. Not only the top part, but the whole base. This thing is hundreds and hundreds of pounds, and there's no way that this could even fit into an elevator.
Yeah.
You know, let alone getting a couple guys.
Pretty much it's where it is, and
right.
Because of what it is, this is where it's going to stay.
So this is kind of a close-up.
Yeah. And you can see how this works. This is the armature, and this is the stator. There's 24 individual elements here. They're all 300 millihenries apiece, and they produce one serious magnetic field. We purposely built 15 ohms of resistance into it, so we had some kind of current limitation because we hadn't really totally perfected our flyback capture processes. And so to limit some current, that kept us from blowing transistor after transistor. But when you do the mathematical analysis, you can calculate that and you know, figure out from there, you know, how much better we can make it. So the whole principle to beat Lenz's law is, if I have two magnetic fields that are clashing, this one is inducing into this one, and this one is inducing into this one, and that's what gives you the conservation of energy law effect, to where, you know, quid pro quo with energy, you know, equal and opposite reaction. Well, you know, and that's all exactly correct. So what we did was very much inspired by Joseph Newman. Very, very brilliant guy. As much as an eccentric as he is, people need to give him credit for his genius. And when I examined one of his motors, I realized that coupling in space was a huge, powerful principle. So that's what this motor is based on, is space coupling. So we have what we call these are horseshoe magnets made with neodymium 4000 gauze magnets. And we call it a horseshoe on horseshoe array. So the paddle here on the armature looks like a horseshoe, and then at 90-degree angles there's horseshoes, an array of neodymium magnets around it. So it makes what we call magnetic donuts, north and south. And those donuts actually sit around, or actually bands on each end around the toroid and not through the toroid so much. And then the switching process is also the rest of it, to where this magnet and this magnet are actually opposing same polarity. So this one is pushing and this one is pulling. But this magnet is open, so it cannot induce any current into the windings and create a counter motive drag. This can create no magnetic field. So the switching, as this thing flies around, this magnet is off, this one is, the one behind it is pushing, the one ahead is pulling, and when it gets right to here, this one turns off, this one turns on, this one turns on, and so you have this gap, this hole in the magnetic fields, and then you have the donut. So you have donuts pushing against donuts in space, and they're not inducing current into the counter motive current into the coils. And so it's totally a motor, but it absolutely cannot generate. And if it's a Lentz-based type, a motor is a generator and a generator is a motor. This is purely a motor because this armature induces no current, can induce no current when the timing's right. And so it's really invisible to the stator.
So like if this coil is on and it's pulling this to it, what happens when it switches off? Where does the recovery go?
Well, that's what the switching, this is what this part down here, all the electronic switches, that's the captured flyback effect, and that's the many multiple effects that we've used to develop a whole array of technology, and it's what we're actually selling now and bringing to the marketplace.
So does it like get sent, recovered in going into the next coil?
It actually goes
to
right back to the switch, and it's saved for the next time it pulses.
In capacitors then?
In capacitors, yeah, exactly. So it's what we call zero stating the inductor. We take it right back to where it's completely magnetically dead. And these coils actually run at 400 hertz. And there's some other things the physicists have always panicked about. So everybody says induction, you know, Henry's limit frequency. Well, that's true if you leave a magnetic field in an inductor that turns around and becomes oppositional force, which is more Lenz's type effect. That's what impedance is, magnetic impedance. I've energized a coil with oscillating electricity, oscillating current, and that current turns right around and becomes an oppositional force that directly and oppositionally opposes the power source. And then your current falls off to nothing, and it looks like you have ohms. It's really impedance, and you cannot drive more current or make a more magnetic field with that source. Well, we drive these at 400 hertz DC pulses, either polarity, and this is a 300 millihenry coils. I can plug these into the wall socket and they won't draw hardly any current. I mean, undetectable current practically. But yet, and that's 60 cycles, yet I can drive 400 hertz pulse current through it all day long. And that's because by extracting that energy, returning it to a zero state, I don't have any oppositional force within that coil that opposes my input current. So I'm able to make incredibly powerful pulsing magnetic fields that I can control with pulse width. And then I can recover all that energy I put into it, get it all back, and put it right back. And that process of returning the current, recovering and returning the current, radically reduces the input watt requirements to make very powerful magnetic fields. So with this particular system, as crude as it is, I mean, we're way more sophisticated than when we built this one. We get a 50% return of energy that cuts the current consumption, watts consumption, down by 50% to produce the same amount of drive by recycling that electricity. And we do it with everything we do. And now that we've reduced the power requirements to drive the head, and now that we don't have to overcome drag force, we've totally altered the Lenzs effects, and we've got incredibly positive results out of it. Now, this is a very crude unit. It spins like mad, and it spins great, but timing is critical. There's no real microprocessor control in it. It's all done with analog and TTL. And so when you want to change speed and stuff, it's a tuning process. But we derived the data that just conclusively proves that we're there. It works. It spins. This thing makes incredible torque. It'll make 15 pounds of torque. And the next go around, we know exactly how we want to do the next one. When we build the next one, it'll be light years ahead of this one. And it's revolutionary, and the Lenzs effects are mitigated or completely eliminated, and hence it's a brave new world.
So this right here, even as crude as you say it is, if you're cutting the power consumption in half, then you're getting, that's a horsepower for under 400 watts.
Yeah, well, what this one, because of the resistance in the coils, we lose a tremendous amount, which means we have to raise the voltage, and we lose a lot to resistance. Mm-hmm. So at 15 ohms a coil, it requires me to have 160 volts to get my 10 amp peaks into my coils. If I just cut the resistance in half, it means I cut the voltage in half, to get exactly the same magnetic field, which means I've cut the watts down radically more than half. And so just by taking the resistance out of the coils puts this machine well over 746 watts per horsepower. And like I said, we purposely had to build that limitation in because, man, we were going through transistors by the bucketfuls.
Or way under 746.
Yeah.
For what year was this built? And
we built it between 2001. It took us 18 months to build it, so we were 2000 and halfway through 2002. And it took us another, it was President's Day of 2003 when we got it to spin for the first time. And it was clunky and it was rough, and then from that point on, then we just refined the circuitry, the timing, brought the voltage up. You know, we started out at 48 and then we brought the voltage up to 160. You know, we got keeping the heads in place. We had to create what we called we had to create a phase lock loop system that could adjust the power, because the head always wants, if it's unloaded, it wants to leap out ahead, you know, because it really creates a lot of torque. So we refined it, and then we took the data off it, and once we got the data, we said, yeah, it's going to do it the way we want it to do it, and crunched the numbers and said, yep, this is an incredible principle, it works. And then we got into business and trying to make a company go to where we could take this to the next level, and this was actually the last thing we wound up patented. It was a 13-year process, because we were always putting this to the back burner to get the finally get the patent granted on it. And now that we have it, that's one of my things I want to do in the worst way, is build the next one.
How is the timing figured? Is there like a mechanical thing on the bottom to tell which?
Yeah, we actually have an optocoupler sensor and a disc on the bottom that feeds the sensor data back to the control board, the phase lock loop board. And then if the thing starts to speed up, it cuts the power down a little bit, and if it lags, it boosts the power back up again. And when you get it tuned up, it's analog, so it's, you know, a little tricky tuning, but once it's there, it maintains its position well, and it will stay in position with load and torque changes. So, and that's what we needed to do, was get it stable. As you can see, there's a timing light right there, and over here on this head there's a little reflector on it, so that when that LED blinks, it reflects on the foil there and tells you that it's in perfect timed position. And then we had to create a little start circuit that flings the head, and so the magnets come up in the right position, because the head can't, if it gets outside the magnetic center, you know, it'll spin, but it's not really working. So it's a very complex process. There's 24 switches that all do capture. If you come over here, things are a little messy in the shop here, so I apologize for that. As you can see, this is the phase lock loop control board here. Pardon the dust and the mess, because I've been in here working a lot. And here is, each element has a switch. This is what we affectionately call our switch. Multipolarity. It'll drive either polarity and 400 hertz pulses to the coil, and every coil has a switch, and there's 24 coils. These neon lights here is how we managed to tame the flyback energy long enough to get our capture circuits. We don't use that. It's ancient technology to us. These resistors were a way where we could feed the captured power out, illustrate that we were capturing the power. These resistors get really hot, could show that we were capturing and burning that energy. And then there's meters that show the current consumption and watts consumption. And as we flip these switches, all the power gets routed back into the machine, and you watch the amperage go to exactly half. Yet the machine actually starts to run better and develop more torque, a little more torque. So 50% reduction of power just by recycling the energy and making electricity loop the inductive capture.
Now, two years ago at the 2013 conference, that was when you first met Jim Murray?
Yes.
2012 or 2013, and then I remember we had a meeting over here in the shop here, and you both realized that you're following parallel paths for years.
Jim has virtually an identical motor.
So would that be the MagnaFlux one?
No, that's his MagnaFlux. He has his toroidal motor.
Or DynaFlux, I mean. Or
yeah, his Dynaflux, exactly. His toroidal motor, you look at it, and it's the same configuration. Jim did a little nicer work. He did machine work and spent more money on building the concept.
Okay. Yeah, that's at I think he demoed that at the end of one of the video tours.
Mm-hmm.
He has is that toroid one.
Yeah, see, and so that's where Jim, we were talking, and it was like funny how the universe works sometimes. We realized that we both had developed exactly the same principle, except his principle didn't involve the space coupling. He was actually doing inductive coupling on the inside of the ring, but producing the same effect where he was not inducing power into the elements from the head of the machine. His only problem was he had to use mechanical switching to make his head spin, so he had a very complex mechanical switching circuit, and he could not master his coils like we do because the electronics, standard electronics are inferior. They're just very hard, because standard switching configurations are not two switches. So when you want to do multipolarity switching and whatnot, they just do not do the job. They blow up. The flyback energy eats them. They create, you can't let them, there's no reverse polarity conditions you can put them in, or they turn on. And so the electronics, so he went to a mechanical system, and he gets great torque out of it, it works, but very complicated switching system you had to build to prove the principle.
Uh-huh. But it works.
But it works.
Yeah.
It works great. Yeah. I've seen it in action, and I've been in his lab, and Jim's got an incredible lab. And the thing is in the meeting of the minds during that energy conference, said, Jim, no problem. We've got the electronics mastered. So you've got that. You put our switching technology to it, your problems are solved, which is another thing that's on our list of things to do.
With his toroid motor.
Yeah, you could literally take his toroid motor and drop it into this machine and hook it up to these switches, and it would go and do what he wants it to do. So we're going to collaborate on that, and right now we're all wrapped up into business. We got all kinds of projects going on. It's a rough world out there, the way the economy is, and business just eats up all our time, and dealing with technology is way easier than dealing with people. So,
right.
Especially money people. So when we get there, that's on our list of things to do, is take this toroid concept and revolutionize motors with it. So there's no reason to spend as much electrical energy as you do in the in the Lentz transformations. To us, Lentz is dead. I mean, it works, but why would you do it that way in this modern age when we have all these beautiful tools to work with, like neodymium magnets?
Are there any updates on SERPs that can be shared with anybody?
Yeah, we've spent a year working on SERPs. We took in some investment money. We spent some fairly serious bucks to prove the principle, and we hooked it up to a generator, built the second prototype, and the principle, as we just claimed, that we would unload the motor and cancel out the drag force in the motor. The other Lenzs effect is 100% accurate and true. There's a lot of tricks to it. It wasn't easy, but we got it perfected enough, and we collected the data. We did fuel studies on actual gasoline running generators, and it's incredible. We above baseline fuel consumption, and as long as we didn't reach heavy duty, there's limitations within generator design that you have to work with and everything. The fuel studies were absolutely conclusive. Same with the torque studies. So now we're in the process of dealing with business people, and that's why I can't talk about it. You know, it's any technology you're trying to take to the marketplace and development just takes incredible bounce money and team effort. You know, we were going to try and work, you know, our first concept was to take it to the public and the small inventors, but we found out it's just not quite ready for that yet, because it's not quite as simple as we had hoped it to be, but we did find all the parameters and proofs, and we're still going to produce a kit and a generator system that people can build and put together and have their own SERPs. And but you know, crowdfunding and that kind of thing just was not going to work to raise the kind of funding we needed.
Mm-hmm.
And the public, it's going to be a boon to the public, and we're going there. And we did a lot of traveling, did some demonstrations to some very serious people. Once again, left them stunned to speechless. Some of them were turned into, you know, and when Jim and I are there at the whiteboard, it's pretty hard to argue with us, and we have some pretty severe and rudimentary math that explains it all. You know, it's what we call algebraic inequality. You know, it's damn hard to argue with simple algebra, and so that's where we're at with that. We're hoping the next year is going to be fantastic. Give us another few months at it. But once again, we've got Flyback as projects going on around the world. You know, we're out there showing what we can do with our technology, and you know, it eats up a lot of my time, and I have a company to run and oversee, and so when we're trying to integrate all this development into that development, and once again, we have to deal with people and finance people and business, and always complicates and slows down matters. But if you want to get it done into the public, it's what you have to do, because most people don't understand the effort and just how much money it takes to do R&D. That's why most companies don't do R&D. They just steal what everybody else does and duplicates.
Mm-hmm.
Because, you know, sometimes you spend a lot of money on R&D and you don't get any results. Well, we've got some incredible results, and we, you know, the principle are what they are. Nobody's subject to Lenz's Law. Nobody's subject to counter-motive induction. You know, it's just everybody that's ever done this and had a prototype that worked and could demonstrate the effects, we're doing exactly the same thing in some form or another. Bedini, Newman, there's just a long list of them. You know, the SERPs, the Tesla principles are all the same. You know, Jim's DynaFlux, it's about getting flux to work with you instead of against you, for at least half the time. And that unloads your prime mover source, and you get the same amount of electricity without the expenditure of mechanical horsepower.
Now with the Jim's DynaFlex alternator, you know, a lot of people want to know a lot more about SERPs, which is, you know, still under development, and it's moving forward and everything. But is the DynaFlex kind of the genesis of the concepts that led to the SERPs?
Yeah, a little bit, you know, and Jim could tell you more about that.
Mm-hmm.
You know, and what's that? I went all through. I've sat right there with Jim, and he's run his DynaFlex motor and the demonstration of it. Incredible job he did building that prototype, and the demonstration where he takes a regular DC motor, you know, drives an alternator, does the power measurement, and then he turns around with clutches, kicks the DynaFlex over to that same DC motor, gets exactly the same watts out of the DynaFlux, but yet the power that it takes to spin that DC motor goes to less than half. Exact same principle.
Mm-hmm.
It's just exactly the same stuff. Jim, you know, with this we're doing space coupling with Jim and you know, the SERPs and the DynaFlux. It's all about getting the magnetic flux out of the way and in the right direction. and creating switched configurations. See, everything up to that time is, you know, closed loop. Anytime I have a closed loop, transformer to motor, transformer to generator, you know, DC supply to DC motor, whatever, if it's closed loop, you have Lenzs, you have the effect, the Maxwellian equations apply, no argument there a bit. When we throw switching in there to route and steer and control the magnetic interaction between the bodies, whole new world. And that's exactly what we've all been doing for many, many years. You know, John Bedini and his machine are, you know, and all the people that he's worked with and that from are using space angle properties to, and the mechanical properties of space angles to mitigate lens effects. So as long as they're switching and pulling power out of the coils at the right time, there's no angular torque that's detectable, and that produces an over unity effect. And I'm not a real fan of over unity terminology, because most people it's real misleading, and in a standard configuration, nobody's going to beat Lenz's law. It's the true physics that apply.
And on Bedini's, you're talking about with the generator action.
Yeah.
With the, yeah.
Exactly. And it works. I've got one sitting right there. I'm in the project on that one, you know. I've spent a lot of time with that, too. And as long as you're switching at the right time, when things are at the right angle, mechanical angles, poof, it puts power out, and there's no drag force that's put against the wheel. And it makes power. And you can... I've watched John do it many times. I've seen it too many times where you are building battery strength up and you're carrying load, and it's closed loop, and you're not, you know, you're not burning external power, and you're actually creating it, you know, it's working, does its thing. You know, and it takes a, you know, and so there's really no mystery to it. It's just plain facts of physics. Tesla was telling us about it. Many inventors between Tesla and Newman. Newman had some great stuff figured out. John Bedini, Bearden, all of them. It's the same principle. It's not cold fusion. It's not ether energy. It's just different. It's just configuring magnetism and making magnetism interact on itself in a sophisticated way that produces much better results. Everything other than solar panels and chemical batteries produce electricity through mechanical force. And so I have to, in order to make mechanical force, I have to have water going over a dam. I got to have wind blowing through a turbine. I've got to have burn coal to make a steam turbine turn. So there's always that cost to create electricity, especially when you're using carbon fuels. A generator, you know, your typical home 4 kilowatt generator burns a gallon an hour to give you 4 kilowatts. So I'm spending $4 for a gallon of fuel, and I'm getting 40 cents worth of electricity out of it. You know, you make a generator, I should be able to reduce that down to 75%. Almost nothing the cost in mechanical force to get the same amount of electricity. And that's what our SERPS experimentation has proved. We've defined the principles, the parameters. We're still, Jim and some other mathematical people are heavily involved right now in defining all the mathematics to it. There's been some incredible mysteries we've discovered out of it that are just mind-blowing that I can't go into right now. But it's an amazing thing, and it's the most, I mean, we're driven people. It drives us. It's our life's work. It's nothing more fun than being in the lab doing this stuff.
Burn copper, not coal.
Yep, there you go. And that was done by my oldest brother many years ago when we were sitting here running this thing, and we just blurted out, hey, yeah, who needs to burn copper when you can, or burn coal when you can burn copper? The copper never wears out or goes away.
Right.
And it's it makes you ask some very fundamental questions about physics that we know the physicists have completely wrong. And it's just a whole brave new world out there for us. And to me, the biggest impediment to all this, and this is what my lecture is going to be about, as much as about all the different things, how we can beat Lenzs laws and all the people who have done it, is the limitation people have placed upon their minds. Belief is the most powerful thing there ever was. And the reason this technology hasn't moved forward at a faster pace is because people believe falsely about electromagnetics, and that belief is so powerful they can't believe it when they see it, things like this, that are different, with different results. And the way to move forward, the biggest thing about moving forward and changing our society and releasing ourselves from the curse of fossil fuels is to overcome, to get people to understand where they can throw away those backwards beliefs that the science community and the industrial community have told people are true physics when it's not. And the more people that change that belief, the quicker this is going to come. And so the public needs to snap out of it, you know.
Right.
They need to start thinking from themselves, you know. Seeing should be believing. And they need to understand that this is all real. And when you start understanding that it's real, and you start aggravating your politician, and you start implementing it, and things become available, you buy it, even maybe it might cost you more money. It's about driving the technology. Even the Wright Brothers, when they first got the airplane to fly and they were demonstrating it to all the academics, there were academics standing there on the ground watching the plane fly overhead saying, somehow you've figured out a way to make an illusion. It can't, I don't believe it. It's impossible, so I can't be seeing that plane. It has to be a hallucination. You know, I mean, so I learned especially with this machine, when we first got this thing running, seeing is not necessarily believing. And so belief is belief and facts are facts. So when you come upon a belief that's been made obsolete by what you've seen and what you now understand, your best choice is to discard that belief and replace it with the new one. And then you will free yourself from those chains. And that's what I've tried to do my whole life. When I come across a belief that I've found to be not true or limiting, that sucker's gone that minute. And it's replaced with what I've discovered.
Yeah, whatever makes more sense. Should evolve.
Yeah,
yeah,
exactly.
Well, thankfully with the conference, a lot of the people that are attracted to coming to this kind of conference, you know, at least they do see that there is a reality, you know, to these type of technologies. Because if we had to bring people to the conference that we had to convince.
Oh, yeah. That's why I do the conference, because it's so heartwarming, you know, because it's a receptive crowd, people that are thinkers, thinkers that are innovators, people with open minds. I can't tell you how many battles I've had with closed mind physics people, to where, you know, I just did one on the other side of the planet here. Jim and I, we had a conference with some people. We were trying to raise interest, some industrial players who could really benefit from the technology, and they had all their engineers and physicists in there, and you know, they were, I mean, I thought some of them were going to go into spastic fits, because we just, in a matter of a couple hours, shattered all their beliefs, and every argument they threw at us, you know, Jim and I just tag team until they folded, you know. I mean, Jim would beat him up for a while, then I'd beat him up for a while, and Jim would beat him up for a while, and we did simple calculus and algebra, you know. And, you know, and a lot of the people there, they had sparkles in their eyes when they left, and some of them were kind of shaky and like they're going into shock. So I've been doing this for years. I've been thrown out of universities. I've been thrown out of big companies. I've been laughed at, scoffed at, but, you know, just because you laugh and scoff and think you know something doesn't mean you do. So nothing new to me.
Well, this is awesome. On my YouTube channel, there is maybe one or two other interviews. Actually, there's several interviews on there that you can just search on my account for Paul Babcock and Jim Murray. And there's a couple before and during interviews before the conference talking about, you know, everything from the DynaFlux, I think, to the SERPs. And one interview we did a couple years ago on your back porch, that's on there. And so you can search those out to get a little more feel for Paul and Jim's work. And I guess other than that, we could probably go on forever, but
Yeah.
but we'll go ahead and wrap it up. But Paul, I really appreciate your time, and
anytime.
you know,
It's all for the cause.
thanks for sharing a little bit more about the motor. I know there's not a whole lot on the internet specifically about this, but if people wanted to look up the patents to see what's, you know, the general operating principles and that kind of stuff.
Yeah, and I would really like to do some videos and with a lot of science ed and whatnot about this principle. But once again, now it is patented, it's company property and not necessarily my personal property. So
Right.
I have to always take that into account.
Right.
So, but things like this, the SERPs technology, we've been doing some things with the SERPs without generators where I can make power meters which almost stop, you know, while the loads keep running on. And as I affectionately call it, my utility killer, but you know, I'm trying to create things independent from the grid so we don't have those issues to deal with and create those kind of enemies. So, and you know, we revived some older type generators that we hooked the SERPs to, and were just astounding results. And you know, as far as I'm concerned, Jim is 100% vindicated with his principles, and the math is astounding. It's just, you know, and it's, you know, Tesla was telling us all along, he was dead right. You know, all the statements he made in his later life where they thought he was crazy, where he could produce massive electricity, megawatts with small amounts of horsepower. It's just, he was dead right. He knew exactly what he was talking about. That's why I affectionately call him St. Nikolai. And you know, it's my deal is that this century become the true Tesla century. You know, the last one has been dominated by, you know, the industrialists and solely for their interests. It's been tremendous amount of damage done to the planet. You know, there's just been, things have been done really backwards. You know, we should have been out of this mode at least 50 years ago. Well, we're going there. We're just not taking any prisoners and not taking no for an answer. And that all comes down to the common man realizing it's all true, changing his belief, and then demanding that our society go that route. And when that happens, it'll change. But that's why it's not really up to guys like Jim and I. It's up to the common folks to make it happen. And be enlightened, man. Don't be a zombie. Be a thinker. Yep. There's two kinds of people in the world. There's thinker innovators, and then there's memorizer regurgitators, and I refuse to be the latter.
Well, on that, we'll see you all at the conference.
Yeah.
Paul will be there probably all weekend long, and Jim Murray will be coming up, and he'll be giving his presentation, I believe, on the same day that Paul is. It'll probably be after Paul's, after a break. And each talk, it's probably about an hour and a half or something like that,
yeah.
about 90 minutes. And like I said earlier, Jim Murray's talk will be kind of like a part 4, you know, kind of extending and
yeah, he's going to go into depth into his
Yeah.
Dynaflux, and I'll probably let Jim do the SERP stuff too.
Right.
The point I'm really trying to get to people's minds to show them that it's just an absolute physical reality. There is no foo-foo science to it. It's just hard and fast physics. There's no, you know, it is what it is, and it's the future, and we can do it right now.
Right.
And for people to get out there and demand it, and just not wait for it, but
Right.
demand it.
Yep. All right. Well, appreciate your time, Paul, and
No problem. It's always fun.
maybe might be able to do one more of these before the conference or something. There's
Yeah.
about 68 days until the conference, and so you can learn more about it at EnergyScienceConference.com. Again, search my YouTube channel for Paul Babcock and Jim Murray, and you can see some of the other interviews, and they go into some of the concepts on the DynaFlux alternator, SERPs, and some other magnetic principles and other related stuff. And so hopefully we'll see you there. All right.
Take care, folks.